this is your Srinivas. Today concept is finders algorithm in ML. Why we are going to use the finders algorithm? By considering the example, we will see the specific hypothesis for the finders algorithm. Let us see what is the finders algorithm. The finders algorithm is a machine learning algorithm used to find the most specific hypothesis that fit a set of positive examples in a data set. That means the data set contains the positive and negative labels. That is, here example is nothing but a record. In the data set, we may have the 10 or 5 records. So in that we have the positive labeled fewer negative labeled. So that I am saying that it is a particularly used for concept learning in binary classification task. So binary indicates that two, that is positive and negative, or we can say that yes or no, true or false, where the goal is to learn a concept or target function that classifies examples as either positive or negative. In the findings algorithm, to find the specific hypothesis, we are going to be considering the only the positive examples or a records. We are not touching a negative examples. And come to why to use the finders algorithm. The finders algorithm is useful in specific context and has certain advantages like simplicity and efficiency. When you need a specific when you need a very specific hypothesis, work well for the consecutive concepts, limited to noisy data as a baseline for other algorithms. These are the reasons for applying the finders algorithm. Simplicity and efficiency. That means the algorithm is simple and very easy to understand, and it only requires the processing of positive examples. I already said that you only consider the positive records or examples, and the steps are straightforward. The operations in it is very efficient manner as it iterations through the data set once and produce a hypothesis immediately. So once we consider the first record, we're going to comparing with the previous one, and we're going to give the immediately we're going to give the hypothesis. It does not require much computational power or complex data structures. That's why I'm saying that it is a simple and efficient. When you need a very specific hypothesis, that means when you need to learn more specific concept that describes the positive records or examples. This can be useful in applying where a clear specific rule for a positive class is desired. Clear? Works well for consecutive concepts. That means here we're going to using the end operation for the target labels. So we can say that when we're going to use the end operation means relation between the attributes. When we're going to consider in the two attributes, what at the time we're going to maintain the relationship. It assumes that the positive example can be described by specific combinations of future values. That means each attribute having some features. Based on that feature value, we are going to be getting the relationship. Next, coming to the limited to noisy data. So if we have the huge or more native target values, then it may not be performed well. So here we can say that it is a simple model and work well if the data has little noise. For example, we can say that do not match the target concept. However, if there is a lot of noise, that is native examples that are closer to the positive examples, the finders may not work efficiently. That is the limitation of the finders algorithm. It is a baseline for the machine learning algorithm task, while it is not the most advanced concept approach, it can serve as a simple starting point, especially in educational context or as comparison for the more sorry, more complex models. Clear? Now consider an example with the problem definition, or come to the step by step process of the algorithm. First, initialize the hypothesis H. First, we are going to initialize in the hypothesis H. Start with the most specific hypothesis denoted as phi, or we can say that it doesn't have any hypothesis, that we're going to place in it null hypothesis, where all the attributes are set to the null hypothesis initially. After reading the next example or a record from the database or data set, iterate through the training examples. That is, each record we are going to be reading. If you have the five records in a database or data set, we are going to be reading with the iteration manner. So if the example is positive, that is the target label having the positive, that is S, then compare the hypothesis H with the example, previous one. For each iteration, if H differs from the example, generalize H by the replacing the value with the attribute from the example. That is, we're going to be comparing. If the both the target value is S, then we're going to be differing the previous one and the current one. So in that, is there any change? At the time, we're going to be placing the generalize with the question mark. If it is the both are the same, we will place the same value there. If the example is negative, ignore it, because finders focus only on the positive examples or records, so that we are not touching negative examples. So finally, the output, the final hypothesis after processing all the records and or the samples, the hypothesis represents the most specific concept that fits the positive examples, right? So finally, we are going to get the final hypothesis with the same data. Wherever we have in the differ, at that place, we are going to get the question mark. Now we'll state the problem statement. We have to find the condition under which a person will enjoy sports based on attributes such as weather condition. Later, we're going to consider in the sky, wind, humidity, like that. Based on the condition, we can enjoy the sport or not. By using the finders algorithm, we will determine the most specific hypothesis that fit the positive examples in the data set. Now we will consider the sample data set with attributes names are sky, air, temperature, humidity, wind, water, forecast. Here the target label is enjoy sport. It is a binary yes or no. Coming to the sky, the features are sunny and rainy. We come into the air temperature, we have the warm and cold. Humidity normal and high. Wind strong or weak. Water all are warm only. Forecast same or change. Based on the records, we have the total five records we have. In that, three are yes and two are no. So while comparing, we are going to be eliminating the two records. Wherever we have the sports, enjoy sports is no. Only the three records we are going to be comparing. Initially, we are going to be taking the five value. Let us see how it is going to be processing. Step by step process. Step one, initialize the most specific hypothesis. First, start with the h equal to 5 value. Initially, it doesn't have any records, so that no information. So we're going to place in the 5 initially in the hypothesis. Here we have the sky, like that we have the attributes. How many attributes we have? Each and every attribute we are going to be placing that. We have the sky, air temperature, humidity, wind, water, and forecast. Totally we have the 6. So that we place the six fives in the hypothesis. Now we're going to read in the first example. That is the we have the sunny, warm, normal, strong, warm, and same. And we have the outcome is that is target value is S. So we update H hypothesis to match this example with the previous. So previously we have the no records. Only we have the 5. So that we are going to consider H equal to first record. That is first example. Now we are going to be reading the processing to the second positive example. So second positive example we have that sunny, warm, high, strong, warm, same. The outcome is S. So we're going to comparing with the current hypothesis. Compare the attribute by attribute. We're going to consider the first one is first attribute is sky. So the sky is sunny. Current and the previous one is also sunny. So it is matching. Keep the sunny. Coming to the head temperature. Current one and previous one is matching. There is a warm. So keep the warm. Coming to the humidity. Current we have the high. Previously we have the normal. This is the previous one. This is the current one. So it is not matching. So generalized to question mark. Coming to the wind, we have the strong in the current and the previous one. So it is matching. So keep the strong. Water, it is a warm previously and currently. So keep the warm. Forecast same matches. So keep the same. Now update the hypothesis. Immediately we are going to get in the hypothesis. So H equal to we go here we are going to keep in the sunny, warm, question mark for in the humidity place, for the wind strong, water warm, forecast same. In the step 4 we are going to process in the third example. Here the third example is rainy, cold, high, strong, warm, change, but the outcome is no. So we're going to skipping this example. That means the hypothesis remains the unchanged. Now in the step 5 we are processing the 4 positive example. That is, we have the sunny, warm, high, weak, warm, same. The outcome is S. So that we are going to compare with the current hypothesis. Same sky having the sunny, air temperature is warm, it is matching. So keep warm. Humidity. The previously we have the humidity normal and high. It is not matches, so that generalized to question mark. Here in the wind, previously we have the strong, current example we have the weak, so it is not matching. So generalized to question mark. Water, it is a warm, it is matching, so keep the warm. Forecast is the same, it is matching, so keep same. Updated hypothesis will becomes H equal to sunny, warm, question mark, warm, same. Next, sixth step 6, we are going to proceed with the example 5. Here we have the record is sunny, cool, normal, weak, warm, change. But the outcome is no. So that we are going to be ignoring or skipping. The hypothesis remains the unchanged. Next, in the step 7, if we have any record, we are going to be comparing. Otherwise, we will go with the final hypothesis. After processing all the examples, the final hypothesis will be sunny, warm, question mark, warm, and same. Why means in the humidity we are going to get in the high and low, in the wind strong and weak. So wherever we are going to get in the S positive records, at that time we are going to get in either normal or high in the place of humidity attribute. At the attribute wind, we are going to get the strong or weak. So interpretation of the hypothesis, we are going to get in the target concept is enjoy sports equal to S is the mostly likely when ఇప్పుడు అంటే sky is sunny, air temperature is warm, water is warm, forecast is same. Only the changes will come at the place of humidity and wind. Can be anything. Generalized as question mark. At that place of humidity, we may get the normal or high. At the place of wind, we may get the strong or weak. So the finally we are going to get the output is hypothesis equal to sunny, warm, humidity plus we are going to get the question mark. At the place of wind we are going to get the question mark. Water, warm, forecast is same. This is the final hypothesis. We can say that this is the final hypothesis we are going to get for this example. I think you followed that how to execute the finders algorithm step by step process. Thank you.